Welcome to the solutions to the Regents Physics Static Electricity problem set, problems number 17 through 19. Number 17, what happens to the size of an electric field if the charge on the test charge is halved? Well, the answer to this question is that from our equation for the definition of electric field, which is force divided by charge, if Q is halved, then the force would also be halved because the force is directly proportional to the charge. So the answer is that no change takes place in the electric field strength. Down here you can see what I've done here is that they've halved the charge, but that means this charge is also halved, and that Fe is equal to Kq1 Q2 over R squared. Well, if we have Q2, which is in the denominator, and it also gets halved in the numerator, then the halves cancel. So there will be no change in the strength of the electric field. Number 18, what will happen to the electric potential energy of a positively charged particle in an electric field if the particle is released and free to move? Well, electric field is defined to be the direction a positive charge would take in that field. So if we took and released a positively charged particle in an electric field, that means it would accelerate. More to come on this when we discuss electric potential energy and electric potential. But what happens is that the electric potential energy will be converted into kinetic energy. Since it's accelerating and it's moving, the electric potential energy is converted into kinetic energy. And lastly, 19. The diagram below shows three spheres with a charge of equal magnitude with signs as shown. Spheres Y and Z are held in place, but sphere X is free to move. Choose the path that sphere X will follow. Well, what will Y do to X? Y is positive and X is positive, so Y will repel X along path D. What will Z do to X? Z is negative, X is positive, so Z will attract X along path B. Since they are equidistant from X and told that we have equal magnitudes of charge, the repulsion from Y and the attraction to Z are the same. So you can see the red arrows here are the forces of repulsion and attraction, and that they set up a parallelogram with the resultant being the green arrow, which is along path C. So sphere X will follow path C, since path C is the resultant of the attraction and repulsion from Y and Z. That'll do it for our solutions on 16 through 19. More to come in the application of electric fields when we tackle problems 20 and 21 in class tomorrow.